Okay, this screencast is about the Big Bang and Hubble's law. Or basically about the Big Bang. And there are a few bits and pieces to this story, which we'll talk about as this little series of separate little excerpts. The first one is the Doppler effect. Okay, so the Doppler effect is a pretty simple idea, and it's the idea that if we have an observer, someone who can register light or hear sound, they're an observer, and let's say we've got a distant star over here. What the Doppler effect tells us, and the Doppler effect applies to both light and sound, but in this case we're talking about light. If this thing emitting light, this star, is actually moving towards us, towards the observer, what happens is the light that is coming from it gets squashed. And because it gets squashed, it ends up becoming bluer in color. And we call that blue shifting. On the other hand, if the star is moving away from the observer, moving away from us, or the observer, then what happens is the light is stretched. The wave is stretched, and so it becomes redder in color, and it becomes what we call redshifted. So if someone like an astronomer observes light coming from a distant star, and they realize and they see it's redshift, in other words, it's redder than normal, that means that star is moving away from us. If it looks bluer than normal, it's moving towards us. Now, Hubble used this idea to look at the light coming from galaxies at different distances. And if this is us here on Earth, and there's Hubble. Now, there's some really close galaxies. Now, this is not drawn to scale. There are medium distance galaxies and there are distant galaxies. So galaxies are all these different distances. What Hubble observed, he actually saw, well, firstly he noticed that the ones that were really close to Earth, like Andromeda, Andromeda and the Magellanic Clouds, are actually moving towards us. So they're blue shifted. Because they're actually affected by gravity. They're actually attracted to the Earth, or not the Earth, our galaxy. Remember, we're living in a galaxy as well. So these galaxies are attracted to our galaxy due to gravity because they're so close. And so they're moving towards us. More distant galaxies, Hubble found that they were redshifted, which meant they must have been moving away from us. And the ones that were even further away were redshifted even more. They were stretched even further. So they must have been moving away even faster. And so Hubble basically concluded that these galaxies, a lot of these galaxies out here are actually moving away from us. And he found this in all these galaxies looking in all these different directions. So he realized that the universe is expanding. And what's more, he realized that the further away the galaxy was, the faster it was actually receding away from us. And that's basically, those two ideas are what constitute Hubble's law. So I'll leave it to anyone to actually look into a bit more detail, but they are the main ideas of Hubble's law. The universe is expanding, and that the rate of expansion is directly proportional to how far away that galaxy is from us. So the rate is proportional to the distance. Okay, so if Hubble then realized that if you run backwards in time, if everything is expanding, then they must have come from some central idea or some central point, and that the term we use when the universe actually came into existence and started expanding was the Big Bang. That was the moment. It wasn't an explosion. It was the moment that that the universe came into existence. And at that moment, there was an enormous, almost unlimited amount of energy. So with the Big Bang, we had an enormous amount of energy, incomprehensible amount of energy. And what actually happened, as it expanded, it cooled. So it expanded, and then as it expanded, it cooled. And eventually cooled enough so that energy could start to turn into matter using the E equals mc squared relationship. So we had energy converting into matter. And from that matter, the first quarks were formed, and then the first hadrons, protons and neutrons, and then from that we had hydrogen and helium. And the whole idea of the Big Bang is simply the fact that the universe started from a single point and expanded. It's continuing to expand. And it was Hubble's observation of the expanding universe that led physicists to believe, well, if everything is expanding, it must have started from some original point. That's the Big Bang, in essence. Okay, thank you.